Previously we have inserted slabs, and the loads supplied are uniform, area loads that was entered in the slab properties. We will now explore how to input other types of slab loads, such as, slab line load. In the plan and 3D view, zoom to the slab enclosed by axis C, D, 3 and 4. Go to the Loading tab. Click the Point, Line, and Area Loads on Slab icon. The slab load dialog will appear. You can insert a point load, line load, or patch area load. Let's start with a point load. For load case, you either select dead load or imposed load, by clicking on the arrow. Key in the load magnitude, say 5 kilonewtons. Read the bottom status bar. It says pick the reference point. Pick the lower left intersection of axes, of the slab. Move the mouse cursor. Click to position and insert the load. Alternatively, press F2 for manual input of the position of the load, with respect to the reference point. Next, select the line load icon, in the slab properties. Define angle equals 90 degrees, which mean it will be a vertical line load. Length of line load, B1 equals 2000 mm, and load values at start, and end, W1, equals W2, equals 5 kilonewtons per meter. Pick the reference point. Move the mouse cursor, press F2, to define the relative coordinates. Enter 1000, 2000, for delta x, and delta y, respectively. Press Enter. The line load is created. Alternatively, you can click on 2 points, to define the start, and end of the line load, without entering the angle, and B1, the length of load. Try this. You can also insert a partition wall load on slab. Click on the drop-down menu under Wall, and select any preset wall loads, which are set up in Partition Wall Loads library. Enter the wall height, h, wall equals 3 meters. Now, click on 2 points to insert the wall load. Let us insert a rectangular area load. Click on the area load icon. Angle allows you to rotate the load, measured horizontal, anti-clockwise. Enter B1 equals 1000 mm, B2 equals 1000 mm. Enter load magnitude equals 7 kilonewtons per meter square. Click on the reference point. Move the mouse cursor. Click to position and insert the area load. Close the slab load dialog. These loads are for practice purpose. Select, and delete all these slab loads. The final model will be a 4-story building. We will now insert the other floors. Go to Building Setout, Storeys drop-down, insert Storey. Alternatively, in the structure tree, right-click on Storey and pick Insert Storey. Input total number of stories equals 4. OK. When prompted to confirm, pick Yes. This automatically inserts Storey 2, 3, and 4. Although created, these new stories have no members at all. Storey will members modeled will have a blue circle marking, in the structure tree. Note, axes are shared amongst all stories. Hence, it's not necessary to copy or create additional axes for different stories. We will now edit the information of the stories. Pick Edit Story from the same Story drop-down menu. The Edit Story dialog will appear. Hold Ctrl key, and multiple select Story 1, 2, and 3. Then click to find selected stories as similar. Under the column Similar Story, we can see exactly which are the similar stories. This means that Story 1, 2, and 3, will now be identical. Since we have already inserted members in Story 1, these members will be automatically copied to Story 2, and 3. In addition, changes to a particular similar story will be applied automatically, to all similar stories. The column H shows all the story heights which defaults to 3 meters, which can be changed. Note, for stories to be identical, they must also have same story height. In a real project, Story 1 is the ground floor, and should have shorter story height, as it's the stump height, and hence should not be made similar. However, since this is just a training model, we will leave it as it is. Level column shows the elevation level of each story. This is with reference to, first story bottom level, input box below, which is the reference level of foundation. The level figures are automatically calculated based on the story height. The level figures are for information only, and have no effect on the analysis. These levels information can be displayed in the floor plan drawings, as well as beam elevation drawing, if preferred. Label defines the prefix label of all members in a particular story. 1. Means beams in story 1 will be labeled 1B1, and columns will be labeled 1C1. We can change this. Type G for story 1, R for story 4. This means that story 1 members will be labeled GB1, GC1. Story 4 members will be labeled RB1, RC1. Description is for your own reference. Example, you add description ground for STO1. Enter roof decryption, for story 4. D1, D2, wall 1, and wall 2 are seismic parameters. Read the notes below when you click on the cell for more information. Imposed load reduction can be applied. If you input 10, it means 10%. Under imposed load reduction, if you click apply, the program will automatically apply imposed load reduction according to the selected code. Click reset to reset values to 0. Effective top story number, and number of rigid basements affects both the seismic analysis, as well as the automatic wind load calculation. Foundation depth. You can enter the footing depth or the pile cap depth, for example. This is for display purposes and affects the 3D view. It has no effect on the analysis. Footing label is the prefix applied to footing, or pile cap label. Footing description is for your own information. Click OK to save and exit. Notice that the 3D view now shows story 1, 2, and 3 with identical members. All loads, including the partition wall loads, are also duplicated. Story 4, roof has no members, as shown in the plan view of story 4. The 3D view, select any slab, press delete. As expected, all slabs in similar stories will also be deleted. Press the undo icon, to undo the slab deletion. Similarly, if you make changes to any members or loads, all members in the similar story will be updated automatically. Activate the plan view by clicking on it. Switch to story 1, by double-clicking story 1 in the structure tree. We will now copy members from story 1 to story 4, roof, to populate it, instead of modeling from scratch. Pick Generate Story from the same story drop-down. Under Source Story, pick Story 1 and then pick Story 4 as target story. Note you can pick and choose what you wish to copy. Click OK and members will be copied from ground floor to roof. Click Close and check that members are indeed created in Story 4. Switch to Show Story 4 in the plan view, by double-clicking on Story 4 in the structure tree. Obviously, the roof is not exactly the same as the ground floor. Create a new slab over the lift core since this is the roof level. A simple way to do this, is simply to select the adjacent slab, right-click, Properties. Then click to insert the slab. This is how you copy the slab. Let us delete all the partition wall load. Click and drag a box to choose all the beams in Story 4. Right-click, choose Delete Wall Loads. Press Escape key to deselect members. Check both the plan and 3D view to ensure the wall loads are deleted. Delete the slab opening too. We will now change the slab loads, as roof loading will be different. We can do it, one slab at a time, by going to the slab properties, but this will be tedious. There is a much easier way, which is to use the slab table. Activate the plan view. Press Escape key, to deselect all previously selected members. Right-click anywhere on the plan view, to expose the context menu. Select Member Tables, Slab Table. The slab table allows all the parameters of the slab in a table. If no slab is selected, all slabs will be shown in this table. If you selected a few slabs on the plan view, then only the selected slabs will be listed. The slab table is a very powerful way to check your inputs, as you can see all slab parameter at once. You can also change any parameters of any slab, one, by simply typing a new value, or selecting from drop-down menu. or you can change it in a batch mode for all the slabs. Click on the header Q, Imposed Load. The entire columns will be highlighted. Click Column-wise Edit icon, at the top. Enter 0.75 kilonewtons per meter square. Press Enter. All the slab's imposed load values will be changed. Close the slab table.